Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account. Hello everyone. Today we have with us Chris Bowen, who is a professor of materials at the University of Bath in the UK. Hi Chris, how are you doing?
I'm doing fine, thank you.
Wonderful. Let's begin by understanding your scientific journey as a researcher, your research career so far. So how did you end up in your current research field?
So at school, I always liked science, and I liked chemistry. I remember I couldn't do the titration at chemistry. I was terrible at it. And I liked science generally. So material science looked an interesting topic to me because it had mathematics, physics, and chemistry. So I did a material science degree. I then became interested in ceramics during the degree. And that's where I selected as a PhD direction, processing ceramics. And I loved the research aspect. So I wanted to continue with that. So I did some postdoctoral time at Hamburg University and Leeds. And then I became a research scientist on sonar. So this is for submarines, defense research. And that's where I became interested in piezoelectric materials, because they send out the ping and they then listen to the signal that's coming back. Then about 20 years ago, I was lucky enough to be offered a lectureship at Bath, and I took that up, and I specialised then in this area of piezoelectric materials, and I've been working in that area ever since, and thoroughly enjoyed it. And my main area is smart materials, functional materials, things that can be used for sensors, actuators, transducers, medical ultrasound applications as well. Yeah.
Okay. All right. That's quite an interesting journey you've had. And that reminds me of your comment about the titration in school. I remember that it never worked in the first 2 or 3 tries.
No. The teacher always, I can still remember it. So he always says, just one more drop, just to get the reaction to gel the colour. No, 2 drops always used to come out. And the teacher said, oh, you've messed it up. And that sort of scared me a bit. So I selected chemistry and material science degrees for undergraduate, but I ended up selecting material scientists and I think it's more appropriate for me as well.
I agree with you completely, because I'm a trained material scientist as well. Yeah. So yes, absolutely, material science is the best.
Regretting. So yeah.
Wonderful. So where and how does, you did speak about your current research a little bit, but in this big picture of materials and nanoscience, where does your current research fall in this big puzzle?
Yes, so the vast majority of the materials that I work on are ceramic. So most of these materials are ceramic in origin. They're ferroelectric materials. So that means that their polarization can be switched by an applied electric field, and these then have ferroelectric domains, a bit like ferromagnetic domains. So certainly they're materials. And certainly there are nanoscale effects to the domains in terms of their properties and their behavior. So within the materials remit, my own research in these materials is in the microstructural scale, sort of at the grain size scale, and certainly looking at microstructural effects on these materials, such as adding porosity, making them into fibers to get specific properties. And as well as ceramics, we then try to make composites out of these materials to try and get maybe mechanical flexibility, because ceramics are inherently stiff and brittle, low fracture toughness. So we combine them with polymers to to improve the mechanical properties, but we can also do that to improve the electrical properties. The sensing properties, for example, can be improved by making them into a composite structure. So it's really a whole range of scales, from sort of domains to microstructure to sort of more macroscopic effects. But certainly it's heavily into the material science sector, and it pushes into the nanoscale science effects as well.
Okay, all right. That sounds really cool, and it seems like you were and are involved in a lot of interesting research projects, which are a lot of fun. So, if you had to pick one, I am sure this is very difficult to do at the stage that you are in. Pick one research project that you're most proud of, or the most fun or a quirky one. Could you pick one research experience or project like this and explain it to us in simple words in the section we call In Other Words?
So I recently finished an ERC, a European Research Council Advanced Investigator Award. So that was a very prestigious award. So so it was a real honour to receive it, and that was a 5-year project. And the main area was energy harvesting. So that's not just using these materials now as a sensor to develop a voltage as a sensor, voltage per unit stress, for example, but to use the electrical energy generated in response to a mechanical vibration, for example, and to use that to power low power electronics. So, for example, you could have wireless sensors that don't need batteries. You're not going to generate, kilowatts or gigawatts of energy with this approach, where you can generate milliwatts, and that's enough to power some low power electronics. So imagine a tire pressure sensor, for example, and those are all battery powered because they're in the tires. You could scavenge and harvest the mechanical strain and self-power a sensor. And that was a 5-year project with PhDs and postdoctoral researchers. We looked at harvesting mechanical vibrations. We looked at heat, pyroelectric effects, linking that to chemistry as well. And it was just the fact that some of the staff, the researchers, have now moved on to fellowships, lectureships, and one's a professor now in a short period. So that's been great seeing those people develop, and also the publications were things I'm really proud of. I'd look at them, I'd print them out. So I'd print them out and look at them and say, look what we've done here. So that's been a fantastic 5-year period, really. And also my Twitter started at that period because I said I would do that, and that's why we're here now, and that's how you've got contact with me. So that's really the real top experience in the last 6 years, I would say.
Okay, so a lot of amazing things came out of this giant project.
Yes, yeah.
Congratulations, 5 years late, but congratulations for winning the award, the Advanced Investigator Award from ERC. ERC is extremely prestigious, and wow, this is wonderful. This is great. And I can imagine why you picked this project, or rather this giant project, as the one that you are proud of. And I can completely relate to what you said. Printing out your papers, your publications, and be like physically having them. Yes, this is it. This is what we did.
I mean, I've written a lot of papers, but I still enjoy every one as if it's my sort of last ever paper. The fact that come from school, degree, go all the way through, and you can produce a nice piece of work.
Yeah, absolutely. That's wonderful. That's really cool. Chris, let's move a bit towards the other sides of a researcher or a material scientist's life, especially in academia, which is teaching. So do you teach? And if you do, would you like to mention any courses?
Yes. So I teach. So I'm in a mechanical engineering department. So we teach a mechanical engineering degree and aerospace engineering and manufacturing. So my main teaching involves material selection, how to choose the right material for the right application. So we use things like Mike Ashby's material selection software, fatigue, high temperature applications, creep, high temperature creep, fracture and fracture properties. So really it's related to those aspects of the materials. Also get involved in the sort of more fundamental material science to explain for engineering undergraduates, why do metals behave like they are? Why are ceramics, brittle? Why are polymers low stiffness? So really a fundamental material science first year undergraduate teaching as well. So it's really across the gambit.
Okay, all right, that sounds good. I especially like the one that you mentioned, how to select the right material. I think this is super interesting.
That's right. Yeah, that's right. So we have Cambridge material selection software allows you to plot a variety of data and do the right selection for lightweight structures or high temperature structures, for example.
Okay, all right, that sounds wonderful. Now let's move back to the research experience a little bit, and not just necessarily the lab, but all the other things around it. And I hope that your experience has been wonderful so far and will continue to be wonderful in the future as well. However, if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here.
No, that's fine. Yes. So I think I'm a bit older now, so but I do feel sometimes a bit sorry for younger researchers in the sense that they have high pressures in terms of metrics, in terms of not just how many papers, but the impact factor and where the papers are, or the way that they're assessed by external bodies. So really to try and just focus on just high quality work and focus on enjoyment, you know what I mean, rather than trying to tick some boxes as well. So I think that would be one way to improve the research experience. I think 2, I don't know if it's a wish, but just really continue working with nice people. So I enjoy working with people who are engaged, who enjoy their work and want to do well. So it's fine, and that's been the greatest fun, I think, certainly the last 10 years of working with people who are so really inspirational and also just a fun to be with. And 3, as a professor now, it's a time maybe not to be sort of just focused on myself and to help others. So I'm hoping that I can help others develop and they can enjoy themselves and develop their own careers. And that's why I mentioned with my ERC the fact that some now are research fellows, lecturers, or even professors. To see them developed is just as much fun as my own papers and seeing the outputs as well. So not to be selfish and help other people. So I think that's sort of wishes and what I want in the future as well.
Okay. Yeah, that sounds really good, and I can completely understand all 3 of your wishes. And it's actually nice to have your perspective, because we did have several, let's say, early career or young researchers, younger, I would say, younger researchers curating the account, and several of them brought up this the system of the metrics and the impact factor and the H index and all these parameters that one measures the scientific performance, so to say. So it's really interesting to have your perspective as well, that you wish that people have more fun and enjoy their work and not care so much about all the metrics and the numbers, particularly.
And
really interesting.
And then the good work will come out of that, rather than just focusing on ticking the right box, for example.
True. Absolutely. I wish I could just say that yes, from tomorrow on, all of this is going to happen. All 3 of you are going to happen. I wish I could say that. However, I would like to believe that we are working towards it. We are working towards achieving all three of, at least the first two of your wishes. And the third one, I'm sure you're working on it yourself.
Yeah, that's fine. Yeah, that's right.
Yeah, absolutely. So speaking of the future, we are living in quite interesting times at the moment. What we would like to understand or ask you is, what are you most looking forward to in the next 3 months?
So yes, when I got that question, given that we're in lockdown, so I think my requirements in the next 3 months are fairly simple, and that's trying to return to some normality. I mean, I think it's unlikely in 3 months. It seems maybe difficult, but I think that we're going to start to return. So in the UK now, we're still under lockdown, still have to stay at home, and the universities are closed. So maybe in 3 months, we'll hope that some of this is so the virus is going to be less of an issue, and there's opportunities for people to return back to work, but only return obviously if it's safe. I mean, I think that's the key thing in terms of work. I think given that we're going to be restricted to working at home, certainly for part of this 3 months is just to help support PhD students, the final year project students, the younger researchers as well, and just to do what we can within the current restrictions. And it's not going to be the same, and that's the key, is to know that's okay. We don't have to achieve what we were doing before when we had full access to the labs and everything, but to do the best we can in that time scale. I think that's going to be the next requirements for the next coming months. And it seems to get a little bit tougher as time, half of it seems to get a little tougher because it's a long period. And then the other half seems to think this is okay because you get used to it. So you swing from those two ways of thinking. But that's really the next 3 months. Yeah.
Yeah, that makes sense. Yeah, absolutely. I can completely. It definitely resonates that part of us is like, yeah, it's all good. This is fine. We are getting used to it. This is the new normal. It's fine. And the other part is like, no, we want to go back. This is dragging on too long. And this is like this tussle between the two perspectives of us. And that's why I mentioned before we started recording, this is like a social experiment or even human experiment on a personal level as well for quite a bit of people. And you're absolutely right that even after the lockdown, we don't know when the normalcy is going to return, but not putting too much pressure also on, especially for PhD students and master students, that you don't have to do things, because I read somewhere that the world you knew, the normal world that you knew a few months ago, has gone out of the window completely. So efficiency has a different definition now.
That's right. Yeah.
That's good. So don't put too much pressure on yourself. That's something to that. Yeah, absolutely. Before we let you go, Chris, so what we want to hear from you is, what are the big challenges that the field of nano or material science facing, and the community is trying to solve? What are the big challenges, big questions?
So as I mentioned, I'm a material scientist, but I'm in a mechanical engineering department, and I think that's interesting because it allows for multidisciplinary research. So I could make a sensor, I could make an actuator, but then I could then apply it in a real situation. So, for example, using a piezoelectric actuator in a hydraulic valve, and being in an engineering department, I can do that. Similarly, a sensor, I can embed it into a carbon fiber reinforced plastic to have some sort of structural health monitoring. So I think one of the future challenges is more multidisciplinary research, where you're crossing the boundaries. Because I think it's very, very difficult now to just work on your own and create sort of something completely new. And I think it's crossing those boundaries between materials to mechanical engineering or electrical engineering to even biology, sort of, and chemical engineering. So combining those skills there and crossing those boundaries and developing multidisciplinary teams, because we're still very focused on departments and disciplines. So maybe we form teams across the boundaries. There's also challenges that who knows is what, due to the current situation, how things are going to change, how the universities are going to reopen in the short term, and also the economic consequences on funding from funding agencies and also industry as well. So there's going to be a lot of movement, and I think that's the key to a younger researcher, to have your core skills and to have your core interests, but also to have some flexibility. So, because I think certainly in the short term, there's going to be a need to be flexible in the directions as well.
True. That makes sense. That makes complete sense. And I hope that the multidisciplinary aspect that you mentioned, I hope that becomes the new normal.
Yes, yeah, that's right. Yeah, that's brilliant. Yeah.
Yeah, that's the new normal we are working towards. I hope so. All right, wonderful. It has been wonderful to speak with you, Chris, and learn about your ideas. So thank you very much, and we are looking forward to having you on Real Scientist Nano.
Thank you. All the best.
Thanks.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.